There are three-digit natural numbers n with the following property. The difference between n and the sum of the digits of n is a three-digit number with three equal digits. How many such numbers n are there? This question tests how familiar the kids are with numbers. I will explain it step by step. Let's assume that n is composed of three one-digit numbers a, b, and c. So what's the relation between n and a, b, and c? Now n is equal to a cross 100 plus b cross 10 and plus c. So according to the text, the difference between n and the sum of its digits is a three-digit number with three equal digits. But now let's look at the difference between n and the sum of a, b, c first. So which means that n minus the sum of a, b, c is equal to a cross 100 plus b cross 10 and plus c minus a plus b and plus c. Let's simplify it so we can get 99a plus 9b. We simplified it even further, we can get 9 multiply bracket 11a plus b. At the same time, let's assume the three-digit number with three equal digits is written as DDD. So according to the text, we just get 9 cross 11a plus b bracket should equal to DDD. Now, what does this tell us? And which property must DDD have? It means that DDD has to be divisible by 9. And let's look at which kind of number is divisible by 9. I think you have learned it in the school. So a number is divisible by 9 if the sum of these digits is divisible by 9. In our case, which means that d plus d plus d is equal to 3d has to be divisible by 9. And which kind of d meets the requirements? When d is equal to 3, for example, 3 cross 3 is 9, it's divisible by 9. Or when d is equal to 6, 3 cross 6 is 18, it's also divisible by 9. Or d is equal to 9, also divisible 9. Now, let's look at each case. So when d is equal to 3, and which means 9 cross 11a plus b should be equal to 333. If we solve it, we can get 11a plus b must be equal to 37. Then we can get a has to be 3 and b has to be 4. We already get 3, a and b. So let's look at this side. How about c? In this equation, there's no c there. So which means the c actually doesn't matter. No matter which c, only when a and b meet this condition, the fourth condition already can be met. So, which means that all numbers from 340 to 349 will satisfy the condition. You might ask me, are you sure? Let's verify. So 340 minus 3 plus 4, which means a plus b plus c is 7. We also get 333. Let's randomly take another one, for example, 345 in the middle number. And then it has to minus 3 plus 4 plus 5 is 12. It's also 333. And they all meet the condition. So we draw the conclusion. When d is equal to 3, 10 numbers can meet the condition. Now, let's look at it when d is equal to 6. And then we can write 9 cross 11 plus b shall be equal to 666. And which means 11a plus b has to be able to equal to 74. Then we get Only when A is equal to 6, B equal to 8, this equation can be met. Same as before, how about C? C doesn't matter. We can get another 10 numbers from 680 to 689. We can also check one of them to see what is true. So 680 minus 14 is 666. Therefore, we can confirm that another 10 numbers can meet the condition when D is equal to 6. Now, let's look at D is equal to 9. When D is equal to 9, we can write 9 cross 11a plus b is equal to 999. And that means 11a plus b is equal to 111. In this case, only to hold this equation true, the a has to be 10, b has to be 1. But a and b are one-digit natural numbers, so therefore there is no a and b can meet this condition. Therefore, the answer to this question is C. In total, 20 numbers can meet the conditions when D is equal to 3 and D is equal to 6. So the answer is C. In the next video, I will explain how to solve question C9. I have attached the question so that you can take a look at it in advance. Feel free to give it a try, and we can compare our approaches to see if we use different methods. Thank you for your listening.